Hi everyone, we're going to find all local extreme values of the graph of f of x equals negative 2x cubed plus 9x squared minus 12x plus 5. So basically what we want to do is find the horizontal tangents, and to do that we need to take the derivative of our function. So we're going to do f prime of x. This is going to give us negative 6x squared plus 18x minus 12. So let's factor out a negative 6. That's going to be x squared minus 3x plus 2. And if we can factor this, we'll get negative 6. Let's see. X minus 1 times x minus 2. Now for the horizontal tangents, our f prime of x must equal 0 here. So that would be so if f prime of x equals 0, then our x equals 1 or our x equals 2. So this is where the local min and max are going to happen for the local extreme values. And let's find out the exact value, and that means your y value. So we're going to take f of 1. That's going to be negative 2 times 1 cubed plus 9 times 1 squared. We're using that, minus 12 times 1 plus 5. This equals 0. And let's also do f of 2. F of 2 is going to be negative 2 times 2 cubed plus 9 times 2 squared minus 12 times 2 plus 5. That equals 1. So now we have to look and see which ones, if 0 is a local min or max, or is 1 a local min or max at our x values. Now, since this is the beginning introduction to local extreme values, you can do it by graphing it. And graphing it requires you to know your parent cubic functions. So if you look at this and it has a negative, that means it's a cubic function that looks something like that. So that's your end behavior. The y-intercept is 5, and this is off scale a little bit. I let my y-axis go by 1s and my x-axis go by 2s. So basically that means we're starting up in here and going through here. Now at 1, we were at 0, and at 2, we are at 1, like that. So basically the graph's going to look like this, something like this. Come up here, and then it's going to cross over here. This gives you an idea of your local min and max. So maybe I should go down a little more like that. All right, it's just a little sketch. So basically this shows you this is your local min, this is your local max. So you would write that your local max value is 1, and your local min value is 0. And this is at x equals 2, and this one is at x equals 1. But this is where your values are. All right. Another way to do it, instead of graphing it, if you're not comfortable with graphing your cubic function, you could just take your two critical numbers, 1 and 2, that's the ones we got, and just do a little sign diagram. You put a 1 here and a 2 here, and we're just looking at the x-axis. So we're going from negative infinity to infinity, and just put some values in. So we're going to look at f of x, f prime of x equals negative 6 times x minus 1 times x plus 2. Now, if I substitute in, say, 0, because 0 is over here, I'll get a negative here, positive. So at, 0, Are these both? These are both negative. I knew I did something wrong. All right, x minus 2. So these are all negative if you substitute in a 0. 3 negatives make a negative. So this is going to be negative. And between 1 and 2, we're going to have to substitute in like 1.5. So this would be negative 1 1/2. This would be positive. This would be negative. So 2 negatives here will make a positive and a positive. So this is going to be positive. And if you substitute in 3, like say put in 3 here, you're going to get negative for your 6. 3, that's going to be positive, positive. So this is going to be negative. And then you could just look at it. These are your critical numbers here. Negative means you're going down. It's a negative slope to 1. And then from 1 to 2, you have a positive slope. So you're going up. And then from 2 to infinity, you're going down. Make it curvy. And you could also see, therefore, your min and max this way versus doing a more formal graph. And that's it. Thank you. Have a nice day. Bye-bye.